Kind of toss into your toolbox, so to speak. Something called a masked move. It allows for control of what bits get updated. So when I copy, normally I have to copy a word at a time. So I have to copy 16 bits every time I do a copy or a move. A mask move allows me to only copy some of those bits, and I can pick any pattern I want. If I only need the 7th bit out of my input table, I can copy just that. Now the downside is that it copies it to the 7th bit of wherever you're going to. So you can't move it from the 7th bit to the 1st bit. Does that make sense? But you copy from 7th to the 7th at least. If you have to go from 7th to the 1st, really the only way you can do that is use an XIC for that bit being on, and then energize the new bit you want turned on. It does execute every time, through every scan. And so as long as that rung is true, it's doing the move. And so sometimes you have to be careful because it could be changing stuff before you're ready for it to be changed. And imagine a box coming down the conveyor, you need to go pick it up. And you say, the box is here, you go to grab it, but it's now here, right? And you miss it. The 3 parameters for it are source, mask, and destination. So source is where you move it from, the source of the information. The mask is the filter. And you go in and you create and you set each of the bits, each of the 16 bits, to either a 0 or 1. If it's a 0, it doesn't do anything. If it's a 1, it copies or moves that bit to the destination location. And I'll show you how this works here in a second. So if I have my input, and where I'm headed with this is the whole BCD, binary converted decimal thing. So if these are my inputs, and I've got something on here and something on here and whatever, but if I only want to copy the first 4 bits and ignore everything else, if I do, or move it, if I do a straight move, it's going to take all 16 and move it down to my destination. And so whatever this binary decimal BCD value of this is, would get put in my number. By doing this mask, and my mask for argument's sake is going to be B31, it's the entire word. I've set only the first 4 bits to be moved. Then what I'm only going to move is this, and all of a sudden now, instead of moving whatever the hell that big number is, I'm really only moving 16, I think it's 24 is what it works out to be. Does that make sense? And so when I do the actual move, when the instruction is executed in the PLC, what copies down from here to there is just those 4. Yes?
What do you mean with the move? Like move what?
In this case, move and copy are synonymous, can be used the same way. But there are some very, very minor differences that I don't totally understand myself. But there's only a mask move, there's not a mask copy. Mm-hmm. So when I say move it or copy it, it's take this information and move it down to here.
To different bit number.
Yeah, and well, in this case, it's actually to an integer.
Okay.
And so this way, I can take these 4 inputs, which are my BCD inputs, mm-hmm. and copy them down to a number, and now I can deal with it as a number instead of as bits. Okay. Does that make sense? And you would do this if you're doing part numbers. If you're saying, okay, start model number or part number of 12, you dial in 12 on the thumb wheel. So I dial in 12 and probably hit a button, and the system was like, oh, okay, go get the number off the thumb wheel and enter it into the PLC so I can decide, oh, I'm doing part number 12 versus part number 8.
Mm-hmm.
Yes.
Which binary did you use to transfer? I see that B3 1.
So the B31 is my mask. B30 is ignore it.
So
And I'm coming from input,
but
my
how-
input, and I'm going to an integer.
But how does it recognize that you're using it? Well, you're trying to transfer input 0.
That's the source. Where I talk about source. So input in this case will be the source. Mask is B31. Destination is N70.
So is that like automatic? That's B31?
No, it's whatever you set it to. And so, as an example, so here's my mask move. B31, well, I'm coming from B31, I'm putting it into B32, or I'm using mask, my mask is B32, I'm putting N70, right? And so if I set B31, and I can go cheat here. Apparently I've set it to, yeah, I set it to 124, right? And I've set my mask to only do those 3. Make sense? And so when I enable this, it's going to put 124, apparently, into N7. And it's going to ignore that bit right there. Actually, it's not going to put 104 in. It's going to put only those 3 bits, which is less than 124. And so let's just do it. And so it moved, instead of 124, it moved number 56 in. Because if I look at it, all right, go here. All right, so I'm taking these bits here, I'm moving them up, in this case, down, doesn't matter. But you'll notice I had 6, 5, 4, and 3, and 2 turned on in my source. But the only 3 that got copied up to N70 are 4, 5, 4, 3. Does that make sense?
Why?
Why? Because that's how the it puts a mask over it and says only do the ones I tell you to do, and it ignores everything else. It's functionally it's doing a Boolean or maybe it's an and. I always forget. But I was reading somewhere an example. Do you know how silk screening works for T-shirts and stuff? Okay, then ignore that.
So the source you mean like in our reality is the thumb wheel? That's the source you mean?
It could be. It's whatever you want it to be. But yes, it could be the thumb wheel. It could be this sensor, which I'm going to show you in a few minutes.
So it's an input.
It's, yes. Well, it could be a physical input, or it could be a bit input. So I can, as you saw, I did it from B31. So I did it from a set of bits. It doesn't care what the source is.
Mm-hmm.
The one thing it does care about is the number or
Converter?
Wrong
BCD to.
the BCD side of it cares, but the mask move doesn't. It'll do a word at a time. It doesn't care what the word coming in is, what the word going out is, as long as the word going out can take it, the destination can take it, and it's 16 bits in length. It'll go from here to there, and it'll only move the ones that I've turned on in my mask.
Okay.
Have you done stenciling? You ever seen stencil? Where you like
Yeah.
spray paint
Yeah.
and you take it off and just the letters there? That's a mask. And so this is the same concept. I put the mask over, spray paint, and when I pull everything away, the only place, in this case, the only place that stuff gets through is where I have the cutouts in the mask. That's what these are, cutouts in the data stream. And so it only passes those 3 values to the destination. Does that help?
Somewhat, but what did you use to just say, I just want those 5, 4, and 3 bits?
I just arbitrarily pulled those out of my ass.
But why would you?
I could have picked any of those bits.
Why ask for a larger number if you're just going to use that?
Because there are times where I don't want to get into something just yet because it's really going to screw with you and confuse the hell out of you. So I'm trying to hold off on getting into that, which is a good example of what a mask move is for. All right, so I'm going to jump ahead a little bit. BCD, binary converted decimal. If you're taking data out of physical inputs, thumb wheel switch, this sensor, which by the way, there's 1, 2, 3, 4 physical sensors built into this unit. And so if any of these, they're all procs, so if any of them see a metal near them, it turns on that output. If you want to do a BCD conversion, you can only do it at the word level. It is what it is. It's the way the processor was written. So, you have to plan ahead a little bit, and as long as all your inputs on your PLC, whatever card they're in, start at 0 and work their way up from least significant to most significant. And so maybe I only have 4 bits or I have 8 bits, doesn't matter. As long as the least significant is here, the most significant is there input-wise. So on my physical inputs, as long as I have those I've got a data stream, right? And so what I want to do is I really only care about the first 4 bits, for argument's sake. I've got other inputs on this thing, potentially. I actually have an input 9 wired in, right? If I do a BCD conversion and the 9 is turned on, my answer is way the hell wrong. Either I have to do the math to correct it, or I can do a masked move where instead of trying to read the entire input table, I'm functionally only reading the first 4 bits. So I mask everything else off, I move the first 4 bits to its own N7 value, and now I have a clean set of bits to do my binary converted decimal on. Does that help? Make sense? Let me show you. I'm going to show it to you here in a second. No, yes. I see the pain. Go ahead and ask.
No, I ain't got no question. But I'm trying
You don't,
to absorb it.
you're so confused you don't even know what to ask, right?
Exactly.
Yeah.
All right, that's fine. There is a gotcha, and that is every time that rung scans, if it's true, it's doing the move. And that can really cause you problems down the road. And so, well, we'll get to that in a minute. Apparently we're going to do the BCD first. And so the 2 instructions for BCD are from and to, so Fred and Todd. It is the word level, and this is the one you have to be careful of. If I do a mask move out of my input table, I can overflow my decimal number. 16-bit decimal is 65535. So 65,000 6553 or 35, whatever, 65535. I just remember that sequence because I deal with it all the time for something else. That's bigger than a standard normal integer in Micrologics. You have to use something called a long. I shot myself in the foot. My little conveyor downstairs, I swapped out the PLCs on it, I put a Micrologics on it, and rewrote the program for it, and like an idiot totally forgot about that, and it kept crashing after about 40 minutes. I couldn't figure out why until I realized, oh shit, math overflow, because I was trying to count and do some movements and everything else into a standard integer which stops at 32,000 and change. And I was trying to dump a count of 1,000,000 into it. It didn't like it. And you'll get that overflow. So the 2 BCD would be usually used where I know I've got a set of information I need to set my outputs in a certain way. I can save the pattern, the bit pattern for the outputs, convert it to decimal, store it as a decimal, and when I say go, I do a 2 BCD and write it to the output table. And so I can set all the outputs in one quick instruction instead of OTE, 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 OTE. Say that fast more than once, right? I'll show you those in a minute. There's also, and so the issue of the rung constantly processing over and over and over can be solved with something called a one-shot. And this is an instruction that allows the PLC to prevent the instruction from continuously running more than once, hence one shot, once. You want to use it on math instructions, moves, copies, things like that. There is a one-shot rising, and a one-shot falling. The Micrologics does not support, the 1100 does not support the rising and falling. So it's just the one-shot. One-shot requires a single bit that it handles. It says, hey, what's my state? And it sets it from 0 to 1 automatically. You don't have to do anything with it. It handles it itself, but it lets or prevents the processor from doing that rung more than one scan. Yeah. The one thing you do have to do is you have to reset the rung, because the way the one-shot works is when that rung goes from false, when it evaluates from false to true, the one-shot allows it to process once and then prevents it from processing again. Now, I could write my own instructions to do that, but it's easier to just do the one-shot. But after it's run, you have to turn it off or you can never get back to that rung again. Now, if I've got something like my controller for the conveyor where I want the light turned on, if the processor is working, I can potentially put a one-shot in to set the conveyor to turn that light on, but I'd have to latch it, and we'll ignore that. Now that I've said that, it's a bad example. I'm trying to think, what would I use a one-shot in the top of a program for? I'm not sure now that I think about it. All right. All right, so go back to my program here. All right. Let's set this back to 0. So all I'm doing is taking the value of N73, adding 2 to it, and putting it back into N73, right? Nice simple add command. When I enable this bit, that thing's just off to the races, and it will run until I fault out the processor, literally. And it just faulted out because I'd used a standard, N7 is a standard integer. So it's 32,767 is the max number I can stuff in there. And I think it might be 68, but either way, that's the max value I can fit in there. I sure as hell probably didn't want it to do that. And so the way you stop something like that do that. Clear. Yes. Set that back to 0. And the way you stop that is with that one shot. And so I've got a one shot at B301. Doesn't matter. And so now you'll notice, hopefully noticed, this only incremented to 2. So I've turned B30 off again, turn it back on. Now it's only 4. So this is only letting this instruction run one time. I could do the same thing on a mask move. Okay. Yes?
Now, can you explain what you tried to do here? Like you want it to be increment by 2? That's
Yeah,
what you're
I
trying
was just trying to do increments of 2. That's all it was.
Okay.
But you'll note, but you should have noticed by putting this in here, the add instruction
time.
only occurs once. Otherwise, it just keeps going as
Yep.
long as that rung is true.
Right.
And
why it stopped at
usually you don't
32?
want it. If you're counting parts, it has to go true, then false before it counts again.
Right.
Hey, great. But for math, it just goes. And so whether I did add, subtract, multiply, divide, square root, it doesn't matter. It's going to keep going. Now, if I wasn't referencing myself, if I wasn't saying A equals A plus 1, or 2 in this case, it wouldn't matter. Because I just keep doing the same math instruction into the same location. And the answer is the same until one of my sources changes. But sometimes you do have to add back into yourself. Think about doing an average. If I want to do a running average, and every 5 seconds I have new information that I'm putting into my average, if I don't one-shot that add, I suddenly have problems. I can't show it to you now because the machine's not on physically, but I'll try to remember for lab to go down, turn it on, and pull up the program for the conveyor downstairs, because I'm doing a running average of the speed. And I have to control when things are copied back and forth, or my average is wrong. All right. So let's ignore those. Let's go to there. We're going to do a All right. So I'm going to do a masked move. Where am I putting N7? So So when I turn on that bit, I'm functionally going to go from, whoops, one too many, my input table, which is here. I'm going to take these first 4 bits because I've defined only the first 4 in my mask. And I'm going to stuff them physically in N7-2. Now, let's see, that was this guy. Input. Oops. All right. And you remember I said that this is going continuously. So that's why I don't have to sit there and hold it or think over it. All right, so I've turned on 2 inputs, right? It's put those in, or 2 inputs, and it's put it in my integer. Of course, if I take that off, it immediately sets it back. Now, here is where the one shot becomes important, or you have to use a physical input to say, do my transfer. You don't want to do what I did in my ladder here, which is just go, right? Watch this. Watch down here. Right? You what? So those bits sat there and started toggling back and forth. Because as this, so what it is, I've got 2 set screws in here. And remember there's 4 sensors in here, and the set screws are spaced off of the sensor. As that goes past the sensor, as it comes even up to line up with the sensor, I'm getting different values. Which value is correct? Well, it should be the last one, hopefully, but that's what I have to be careful of. And that's where that one shot can potentially come in and play and help out. Is this making what I've been talking about so far a little more clear? No. Brain just frozen this morning, is that the problem?
I just don't understand the concept of the mass move. So why do you have to create so many rungs just to get the
So right now, if you look at the input, the middle one here, 9's turned on, right? The mass move means I don't copy down 9.
It just copies the first state.
Right. And the reason I care about that is if I convert both of these to decimal, what are we looking at? 2? Yeah, N7.2. So N7.2 there, right? You'll notice N7.2 is 9, which is what it should be. But the input value is 521. 521 is not the right answer because I've got, if I remove that additional sensor, now I've got the correct 9 because I only care about the first 4 bits. When I try to do my BCD conversions or whatnot. And so as far as the number of rungs, really the only rung you need is this guy. Because he's moving it from the input table through the mask straight into N7. I don't actually even need to do the from BCD, the FRD instruction, do I? It's a shortcut in a sense. Not always going to be the case though. So this was just to show you that you can write to second binary file instead of to straight to the N7. And not that it makes a whole lot of difference. Oops. Here's the from BCD instruction. And so there it's pushing the 9. So this sensor that I've been playing with, like I said, it's 4 things, so I can do that. I can do that. Oops. Ah, see? I just faulted it. Because as I was fiddling around, I triggered something that shouldn't have been triggered. And it should be... whatever. Not sure why it faulted, actually, now that I say that, now that I look at that. I can pass it all 4 at once, and
Faulted again.
that's interesting. All right, so B3.4, what's in B3.4? So I am not sure why it faulted that. It shouldn't have. Well, that sure shit is, though. Oh, it's because I'm coming from B3.4. I'm not coming from the input. Huh. I don't know. Because B3.4 doesn't have anything far enough out that should matter. That is interesting. I'll have to look into that. I'm not sure what it's doing. Should only be 32, I think. Yeah.
That's weird.
Yeah, that is weird. All right. I'll have to figure that out. But what this thing is used for is I can put these onto parts holders and pallets, for lack of a better term. So these little trays on the conveyor that are running around. I put a block with pins on it, and it's hard, it's not the best video, I couldn't find a better one. I've got another one, but it's not much better. I can now tell what pallet is in front of a workstation when it stops it. And there's a read head right there, it looks like, although it's a different style. So it's saying, okay, is it product number 2, product number 3, what is it coming by? And without having to use a barcode scanner or RFID or something else, I'm able to identify uniquely each of those pallets that went by. And so this hardware is from Bosch. They make really neat, cool pallets and conveyor systems that are freaking expensive as all get out. That system there is probably about $15,000 for what little you see. Greedy Germans. But it is actually really nice. These pallets, by the way, are steel plate. They're probably about 15 pounds a piece. Maybe they're aluminum. Okay, so they still make them so big and bulky, it's only 12 pounds. You do not want to drop one of those on your foot, trust me. All right, but that's where you would use this sensor. And so the reason we had it, I was going to have some students try to integrate it in with one of their senior design projects, and they wimped out on me. After I bought it, they decided not to use it. But I'm trying to get it up and set up and so we can play with it. Let's see. Talked about those, talked about that. And go away. So, first test is going to be Friday. Relay logic, wiring diagrams, be able to write programs up to what we've covered so far, understand the instructions. And when I say understand the instructions, I might ask you what bits are associated with timer on, and you would tell me that a timer timing, timer done, timer enabled bits, right? So the TT, the EN, and the DN. Are there any bits associated with an XIC command? No. Right? Count up or count down. Counter done. About it. I may provide some ladder logic without comments and ask you to tell me what the ladder logic is doing. And when I say something like that, it'd be, okay, here's what is that rung doing?
Just turn on the light or whatever
Right.
is the output, and it
But-
latch it so it
but
can.
it's latching it.
It would.
Yep.
It won't have.
And so if I gave you something like this, you'd tell me it's latching. What kind of logic is that?
It's timing, it's like 10 milliseconds timing.
Yep. It's 100 milliseconds.
100, yeah, you're right.
That's fine. Remember the debounce, the conveyor? So this has to be turned on for 0.1 seconds before I acknowledge that the part's really there, right? So when I ask a question saying, tell me what the ladder's doing, that's the type of stuff. And so I'm looking for a sentence and really when I go to grade it, I'm looking for keywords. Latching, debounce, anti-tie down, things like that. And then I may put a partial wiring diagram in the test and say, okay, where is part present photo I? What is the input address for the part present photo I? And you'll have to be able to look at it and say, oh, okay, based on the way the wiring diagram was done, so if I did something like this, part present is wired to input 1, right? Make sense? Easy enough, don't need to give the test, you guys already got 100 on it, right?
I mean, if you want to take that, that'd be great.
All right, questions? Lab today, play with this guy, get your programs working for this, right? I'm sure you all thought about this extensively over the weekend. Yep. So you're making my wife be correct. We're supposed to stick together, guys. Hopefully, I'll have this rewired. I got my little adapters done. Now I need to cut all the wires, relabel everything, and do that so we can swap these out easily. Because the plan is then, I'm going to take this, I'm going to plug it into Compact Logics. You have to write the same program for Compact Logics, just so you have a point of reference with the exact same hardware and everything else, just so you can see what the differences between the software packages are. They're not that big a deal, and in some cases somewhat profound, so that's where we're headed next. Because we pretty much covered all the basic instructions. The last couple instructions are not too bad. I'm not going to throw anything really new at you guys on Wednesday, but I don't know what we're going to do Wednesday yet. All right?
Yes.
Is this mass move going to be part of the test? Or?
Yes.
Okay.
All right? It'll be fun.
More than that.
What I might do for Wednesday is come up with a couple of activities that use the mass moves to help me get a little more comfortable with it.
No worries. That'd be great.
Of course, I'm not sure what the hell what those activities are going to be, because in some ways there's not a whole lot of use for it. I'll be honest. I don't think I've ever used it. I've always cheated and just done straight over to, well, yeah, no, I don't think I've ever used it. I allocated a I/O card or an input card for my thumb wheel, partially because I needed so many damn inputs on my thumb wheels. And so it didn't matter. I didn't have to mask anything out. It just worked out that way. All right, let me go figure out what you're gonna do here. It's fired up on a computer.
Yeah, I'll get it started and then I'll be right
Yeah,
back.
yeah.
Well, you thought, yeah.
We talking about the beginning of this class, or the beginning of the lab?
Usually it's beginning of this class.
Yeah.
God. That's what we did last time. Or the end of this class, really.
Yeah, cause man, I could.
So I'm not sure how truly applied it is. I've got an example for the mask move. And that's interesting. That's a 0, not a 1. Idiot. All right. Make a quick fix this. Save it as well. Thought that was. All right. All right, so the way I've got this set up, when I push the unused button here, it toggles this light, right? So if I do a mask move, and my mask is B2. So I'm only turning on 1, 2, 4, and 5. All right? Everything else I leave alone. So when I do the mask move, we get 1, 2, 3, 4, right? We don't get this guy because that happens to be the auto manual light. And so I would want to normally leave that alone. I'm also leaving this guy alone because I'm still able to control him. And then that just clears everything, so everything's off. And that is on, yep. And so, as you can tell, these two lights are not being affected. So if I have a bunch of outputs and I know I need to preset a bunch of outputs for an operation, a mask move is an easy way to come in and say, okay, write all the settings at once, done, but only turn on and off the ones I want to turn on and off, because the other ones might be a light stack or a warning horn or who knows what it is, but we don't want to turn those on necessarily. Does that help make a little more sense from this morning's discussion? Ish. All right, I'll see if I can continue trying to come up with examples of when you'd want to use a mask move that's outside of something called a sequencer, because that's really what a sequencer is doing, and a sequencer is nothing more than the logic that controls your washing machine. So you start cycle, fill, and then it stops. Once it hits a certain point, it stops. It goes to the next part. Agitation, next stop. Empty, next stop. Drain, next stop. Refill, spin, drain, right? and that sequence is turning on and off different inputs and outputs at different points in time, but we're not going to get to those just yet. So that's really kind of where a mask move makes, in my mind, the most sense. But I have used it for presetting outputs on stuff I've done as well.
Makes more sense now.
Okay. Well, does it make less sense than before? Have I gone the wrong way yet? I'm going to call it a win and keep working on it. Questions about the lab project for this guy? So one of the things that you are inevitably going to have to deal with, and if you don't believe me, turn around and ask the guy sitting back by the robot. Someone's going to hand you a piece of equipment or point you at a piece of equipment and say, make an update to that, and there ain't going to be no damn prints for it. Because someone lost them, never done, files corrupted, never done, something has happened. And so, as part of the lab assignment, you guys get to document this bastard. Now, the good news is, I'm being reasonably benevolent. We are putting labels on the wires. And so, the wire at the PLC, you can come along and see what's going into the PLC from what point. You don't actually physically have to trace all the damn wires. And this has got 24 wires, it's not bad. I mean, if you want ugly, take a look at behind the 4-screen monitor, look inside of that thing and think about having to do all the wire tracing for that sucker. You better hope you're being paid hourly at that point. Because if you're being paid by salary, which means if you have to work overtime, sucks to be you, it comes out of your hide to get it done on time, you're going to hate life. I'm working on getting some not so quick disconnects wired up for this stuff, so that I can swap this over between pieces of equipment. But that should be fine. You can look at either the PLC level or where these join and read off the labels. You only have so much room, so the descriptors are kind of thin. L jog, L-dash jog, R-dash jog, left jog, right jog, right? L start, R start, left start, right start for those puppies, okay? So you're gonna have to create from scratch a print for this. And oh, by the way, part of it's DC, part of it is AC. The light is AC. The MCR is DC. I think it's just the light that's AC. I think everything else is DC. No, all the lights are DCs, or are AC. So not only this guy, but all the small ones are DC as well, I think. Or AC, excuse me, yes. 120 AC. So any light is AC, everything else is DC. Make sure as you create your print, you're pointing to the right voltage on things. You don't have, for the panel itself, I mean, just go into PowerPoint or Visio or something and just draw a representation of it. I'm not concerned about the exact size and dimensions and all that crap. All right? It's here. Get your logic working first. You've got the I/O listings already anyway, so it's not like you have to go and map those. You just have to draw it up, really. But I would program it to your individual PLCs for testing, and then when you think you have it, you can come over and try to physically do it.
Okay, so these I/O listings are the real I/O listings for that panel?
Yes,
Okay.
they should be. I don't think I screwed that up. If I did, it was not intentional.
Well, we're going to be making a print anyway, so we'll figure it out.
Yeah.
That's we're supposed to submit that separately along with the,
Yeah.
with the RS Logics report?
The RS Logic report, the schematic is one report together.
Okay.
And you can do a cover page and then an initial page just describing what the system does. So you can pretty much take what I wrote, put it in your own words and own descriptors, and that's the description of the machine and what it's doing.
Okay.
All right? All right. How about it? I'll be floating around.